A very good evening, dear hiring manager. My name is Rudradev Arya. Uh, thank you, first of all, thank you for the opportunity of uh, giving me the assessment to prove myself. I'll just start right over here. This is the overall task list that I uh, imagined from the problem statement given. First was to create clusters with multiple workers, an API cluster. Give rate limits to it and queue uh, create tasking queues using whatever we want to use. On top of that, I tried to do it in TypeScript and also tried to implement some testing for rate limiting and queuing. I was also trying out Docker, but unfortunately that didn't work out. But I have still committed those files, so if you want to see how I tried to do it, you can see it. This is the general folder structure that I thought of, which the source file basically has four main files. First is obviously the app.ts. The the app.ts basically is the main file which is setting up the worker processes. It is also the express application, and it is also middleware kind of thing which is doing the rate limiting. It also defines the API routes which we'll see in the in VS Code. The config.ts that basically uh, is created for easy modification and testing stuff out, so that we don't have to go every time in the app.ts and update it. Same logic was for type.ts, which basically houses the request body and the request response, so we can configure it from there if we want to change the response in some way or some form. Task processor is the main logic which uh, handles the rate limiting, uh, logs the logs the completed responses, and also Redis for queuing using queues. I have not used BullMQ here because I didn't think it was necessary for the constraints of this problem statement. Uh, to install, you basically need to clone it, and all the dependencies are already set. So you need to just compile the TypeScript file into JavaScript, and just start the server. I'll obviously demonstrate it further. Uh, this is also the small documentation here to demonstrate what the request body is supposed to be and what the expected responses are supposed to be. I've also attached outputs just for convenience sake. Uh, this is the config file that I mentioned earlier. This is just handling workers and log files so that we can handle without going into the main logic and changing stuff there. These are the tests I created for queuing and the rate testing. The main logic here is in the task processor, where the Redis logic is implemented in async functions. I'll demonstrate by running. Right, I'll start once more. Basically npm start, which will create a primary node and two worker nodes who are given these IDs, and obviously they are running on local port 3000. Now it's currently waiting for uh, an a post request from an API in the API. So use curl and postman both. So in this example, I'll just, you can see here in the top, in the same user ID, user 123, I've done more than 20 times, and it shows the task is queued successfully. And if I do it after more than 20 times in a particular time period, then obviously it will say too many requests, and it just holds us in a queue. To demonstrate in the Redis, I'll just use user 1 year, task queued successfully. In the Redis CLI, you can see, okay, oh, it's in a different port. Okay, any which ways, as you can see here, it is logging on the terminal, and it would be in the log file too. It's time stamped with the username and whatever the task completed message is there. Also, there is a tsconfig file which specifies that the compiled JavaScript would be in the dist folder. So that's where it would be running from. In the Postman, this is a previous example that I did, uh, which is cluster test with, this is the body, uh, just a user's name. If I run it for 24 iterations or more, even 20 iterations, you can see it is giving 200 OK for every request. But immediately after 20th iteration, the iteration 20121 is gives the response too many requests. So it works properly. So that was basically, I think, uh, fulfilling all the needs requirements. Two replicas were set, the two worker nodes created, and implementing the rate limiting also demonstrated on curl and postman. Also the queuing system to manage each user IDs. So obviously these were different user IDs, router one and other one was user one, whatever the case may be. So that is also done. uh, the tasks are also logged here, and we also saw the queuing, and in the queuing in the Redis, uh, and on the point of resiliency to failure and edge cases. That's why using TypeScript can be beneficial, because it would basically type check every input based on whatever the parameters are there. uh, we could also There are also multiple edge case handling inside the code uh, that has been implemented for certain edge cases, like different input or invalid input or something like that. So basically uh, that was my submission for this assessment. Thank you. I hope to hear from you soon.